Hello and welcome to this session of Introduction to Autonomous Systems. In this segment, we will talk about the various mechanisms of interpreting the probability and the basic philosophy of Bayesian update. So, let us begin. In order to understand the whole idea of probability in Bayesian interpretation, we need to introduce two broad points of view regarding the probability itself. So, there is one point of view which sees it as dispositional properties of non-deterministic physical systems, for example, gambling devices, which employ the basic concept of frequentism. I am sure all of us understand that frequentism is essentially the basic assumption that there are large number of trials, and under those large number of trials there is a certain type of probabilities that can be expected. Now, other point of view which also has gained ground is that probability is essentially a reporting of our subjective degree of belief. In fact, we are kind of used to saying that I think there is a 30% chance that it will rain. So, it is our belief, and that number that we have quoted is essentially a reflection of the probability that we have in mind. Once we accept this idea that probability can also be looked upon as a subjective degree of belief, we can now take it forward and say that this is what the Thomas Bayes actually subscribed to in terms of the interpretation of probability, and that also became the basis for the Bayesian theory and Bayesian networks. In fact, people have kind of come to understanding or realization that Bayesian interpretation also is more general. The reason being that we have subjective belief in a huge variety of propositions that may not have anything to do with infinite trials for a physical process. I mean, infinite trials for a physical process like tossing a coin or rolling a dice, they are all very specific cases of random events. There are a large class of uncertain events where there may not be any trial. They may be happening for the first time. So, it makes lot more sense to talk about probability as subjective belief rather than coming from frequentism. And many people believe that Bayesianism is the generalization of the probabilities associated with physical processes which are also treated as a quantitative measure of subjective belief. So, which means now we can kind of connect a probability number as a kind of a quantitative measure of our belief, and it is also in some way based on common sense. I mean, this is how we view probabilities, that there are events for which we have belief, and that belief has a quantification which in our opinion is equivalent to having a probability. So, the Bayesian philosophy starts with statement of a Bayes theorem which is stated as follows. Now, here as you can see, the Bayesian theorem has directly borrowed the idea of conditional probability that we discussed in our earlier probability discussion, that probability of a hypothesis H in the light of an evidence E is dependent on First, its probability before this evidence occurred. So, that is what we call the pH. Then the actual probability of that event or the evidence being true. So, that is PE. And the third part, the probability of the evidence E being connected to hypothesis, that what is the connection between this evidence and the hypothesis being true, that is PE vertical bar H. So, you realize that this is essentially a translation of the conditional probability that we have seen earlier, but now in the form of a different semantics, where we propose it as a theorem where our prior probability of a hypothesis H gets modified in the presence of an evidence. And this you will realize is essentially the process that we need in order to get probabilities for any hypothesis being true in the presence of evidence, which in the context of our intelligent rational agent would be nothing but the percepts received through sensors. Assuming that the percepts are the real world scenarios, the implication of the percept in terms of a hypothesis being true is what this particular theorem establishes. And some people say that P H vertical bar E is a posterior probability of hypothesis H, whereas P H is considered to be its prior probability. So, there is a connection between what happens after the evidence is arrived at or is obtained or available, and what happens to the probability of that hypothesis being either true or not true. It can be in both ways. So, this becomes now also, as we are talking about subjective degree of belief and probabilities, it also becomes kind of a posterior degree of belief in the hypothesis. So, now we say that this P H vertical bar E is nothing but our quantitative belief in the hypothesis H, and where BEL represents a belief array, and it will contain the values for all kinds of hypotheses that you may have in your hypothesis space. So, if we were to summarize this part, we would say that under the condition of a new evidence, probability of H as calculated from the Bayes theorem is the new posterior belief in the hypothesis. So, you have a belief in hypothesis, and in the presence of a new evidence, you now have a new belief in the hypothesis. So, what are the implications of this theorem? One of the things which also is stated is that the ratio PE bar H by PE is sometimes called the likelihood of H. Say that what is the likelihood of H being true, and that is normalized by the likelihood of the evidence, which means that what is the likelihood that evidence E is true, and what is the likelihood of that evidence being connected to the hypothesis being true. Of course, everybody will agree that this is a non-controversial theorem, and it is entirely based on the calculus of probability, in which sum of probabilities of all applicable hypotheses is set to 1. Once you do that, you go back to your basic probability calculus, which says that probability of U, the universe, which in this case would be the universe containing all the hypotheses for a particular event, is set to 1. Of course, there are detractors which say that is this the only way we can adjust our belief in hypothesis given the new evidence called conditionalization, and there are kind of different viewpoints. We will not get into that, but we will still make a statement that one of the kind of you say a negative impression that it gives is that there is an assumption which is implicit in this whole theorem. The assumption says that there is a pH which is available. Now, generally when the process is continuing, there will always be a pH probability of a hypothesis being true, but whether that would be the correct value to start with is not really verifiable, or you cannot prove it. So, and more importantly, the probability that there is PEH available, evidence being connected to hypothesis, is also somewhat subjective. Of course, despite its various limitations, the Bayesian approach does provide significant support to many such problems for which we have only belief, but that is interpreted as probability. In this context, I want to recall some discussions we had earlier with regard to medical diagnosis, where again a doctor, by looking at some initial symptoms, may have some impression about the nature of the disease, but with some tests conducted, its belief may get modified. It could either strengthen whatever the initial belief was, or it could weaken. Both are equally possible. In fact, some people say that this probably is the reasonable way of doing. For example, suppose there is a crime which has been committed and it has been reported, and we believe that we have 10 suspects for that crime, of which we do not know who is the guilty person. And when we have and the police investigate, initially they will assume all to be equally guilty. So, that becomes your prior probability of their guilt being true. So, we assume that all of them have the probability of being guilty 1 by 10, and then as more and more evidence comes, we can use Bayes' theorem to update this probability, and depending upon the nature of evidence, one or more of one, their probability might be kind of increasing, and you may say that okay, this person seems to be more likely to have committed the crime. So, you can see that it actually is quite intuitive and common sense based, that the prior probabilities do exist, except that initial estimates are quite approximate. And despite all these small issues that are there with Bayesian reasoning, it is still possible to employ it for a reasonable conclusion, which is our primary focus in the context of intelligent rational agent, where we need to come to an inference based on which we will have to take a decision. And another what you call support that comes to the Bayesian theorem is through what is called Jeffrey's conditionalization. What it says is that while the evidence may not be total evidence, so there is a requirement that the E has to be the total evidence before you can do that update using the Bayes theorem. Now, in theory it is a good hypothesis, but in reality it may not really happen. Your evidences may come sequentially, that depending upon how the investigation proceeds or how the various tests are done for the patient, different time different tests will come. But every time a test report comes, you still go and show it to the doctor, and doctor gives an opinion. maybe for further tests to reconfirm or rule out something. So, it is very likely that in most cases the E may not be total, but what Jeffrey's conditionalization says is that even the partial inputs are useful. So, the way the Jeffrey's conditionalization works is something like this. So, what it says is that if an observation does not correspond to a specific evidence E, but only to a posterior shift in belief about E, which means sometime there is an evidence which does not really support an observation, but it just gives you an impression that your belief about that particular evidence has changed. So, you can still use this to update what is called probability kinematics as follows. So, you say that belief in H is belief in E multiplied by the probability of hypothesis H being true in the presence of E plus the belief in negation of the evidence E multiplied by the probability of hypothesis being true in the event that this evidence is not true. So, you kind of use this logic to say that based on this, now if you can clearly see that if the probability of its negation and probability of it being true, depending upon their numbers, you will find that your belief in hypothesis can also get modified. So, even if you do not have total evidence, even if you do not have any connection between the observation and a specific evidence, you can still make use of Jeffrey's conditionalization to update your posterior belief in hypothesis H being true. So, let me give you an example. Suppose we have seen a colored cloth in bright light, let us say it is a green in color, and then suppose we are shown the same cloth in candlelight. Now, it is possible that we are not very sure what the color is. For example, the green color might resemble close to a blue, close to black, close to dark maroon, it could look like any of those. So, you may not exactly know what the color is, but you can definitely say whether it is a dark color or light color. So, which means to that extent you have learned something when you have seen that cloth in the dim light, and this is exactly what the Jeffrey's conditionalization is trying to say, that even if you have only a partial information about a particular observation, it still has the potential to change your belief. So, at least you can say that it is not a light color, and of course, it is also intuitive to realize that this partial information would definitely result in certain amount of shift in our belief about quality of our visual experience. Of course, we know that this process is not strictly valid, because it does not have any mathematical or a quantitative basis. You will realize that this can be an extremely useful practical tool for partially updating the Bayesian models, which means even if your evidences are uncertain in their own way, your observations are not fully alive to what the evidence is being shown, you may still be able to make some corrections, some adjustments to your Bayesian models. So, to conclude this part, Bayesian philosophy proposes that probabilities are a quantification of our subjective belief about various events, and we know that while this strategy is quite useful, there are limitations like assumptions of joint priors, brings in an element of subjectivism, and the technique is somewhat approximate. With that, we come to the end of this particular segment. In the next segment, we will take these ideas further. So, it is bye for now. Thank you and see you in the next segment.